Kia ora, and welcome to a lesson on Cambridge Mathematics P3 Improper Algebraic Fractions. To understand improper algebraic fractions, the first thing to remember is what is an improper fraction. So 11 over 5 is an improper fraction, and we often want to change that to what we call a mixed number. And the way to do that is to divide 11 by 5, which gives you 2, and then say what's remaining from this, which would be 1, and then you put that back over the original fraction. Okay, and it's often seen as written as 2 and 1/5. Okay, what we don't write is the fact that there's actually a plus in between these two. Okay, because it's actually 2 plus a fifth, not just 2 1/5, it's 2 and a fifth. Okay, so what we're going to be looking at today is how we can change improper algebraic fractions to mixed algebraic fractions. So we can do this when we have a function such as px divided by another function qx where both are polynomials. So where px and qx are polynomials, and px is greater than or equal to, the degree of px is greater than or equal to the degree of qx. Okay, so what that means in practice is that whatever the highest power on top has to be greater than or equal to the highest power on the bottom. You can't have a higher power on the bottom than on the top. Okay, so let's have a look at an example for this. So here we go. We've got x cubed minus 3x squared plus 7 over x minus 2. Okay, we can change this improper algebraic fraction to a mixed algebraic fraction because the degree on top is 3, whereas the degree on the bottom is 1. Okay, and both are polynomials, i.e. there's no negative or fractional powers. Okay, so to change this improper algebraic fraction to a mixed algebraic fraction, we just have to do the same thing that we did with the improper fraction, where we divide the numerator by the denominator. Okay, and hopefully you've learnt how to divide polynomials, and if you haven't, I'd suggest going back and watching a previous video on this that I have done or someone else has done, so that can help you understand where this next process is coming from. So we're going to divide x cubed minus 3x squared plus 7 by x minus 2. So we're going to use long division, x minus 2 on the outside, and we're going to put our x cubed minus 3x squared plus 7 on the inside. However, there is no x term, and it's just good practice to put plus 0x in there so that you can subtract from your x terms later on rather than having to create a sort of third theoretical column. So if you've got no x's or no other terms that may be missing in the sequence of 3210 or 43210, if any of those powers are missing, put a 0 amount in just so that you can deal with that later. So how many times do we have to multiply x by to get a term involving x cubed? Well, that would be multiplying by x squared, so we're going to multiply x minus 2 by x squared, which is going to give us x cubed minus 2x squared, and we're going to take that away from our above line, giving us x cubed minus x cubed, which is nothing, minus 3x squared minus 2x squared, which is negative x squared, and then we're going to bring down the rest of our information, plus 0x plus 7. Then what do we have to multiply x by to get minus x squared? Well, that would be minus x, so we're going to multiply through by minus x, so minus x plus 2x We're going to take away. This is why we put the 0x in, because now when we do minus x squared, minus x squared minus x squared, you end up with nothing, and we've got our 0x minus 2x giving us minus 2x. Minus 2x plus 7. Okay. Then what do I have to multiply x minus 2 by to get rid of minus 2x plus 7? Well, that would be by negative 2. So multiply that by negative 2, minus 2x plus 4, take it away, 7 minus 4 is 3. Okay, and that is our remainder. Okay, so the answer to this as an improper fraction, or the solution for this as an improper fraction, is going to be x squared minus x minus 2 plus 3 over x minus 2. So that is how we can change this to an mixed algebraic fraction. Okay, you take, so where the x squared minus x minus 2 is the whole amount of times it divided in the same way, the amount of times 5 fit into 11 was 2 times. Well, the amount of times x minus 2 fits into this is x squared minus x minus 2 times. A bit more complicated, but it's the same principle. And then just take our remainder, chuck it over our denominator, and that is the solution. Okay, hopefully you understood that. It's a fairly small concept for now, and it will develop into something larger probably at a later date. So thank you for watching, and hope you come again soon.